Hey guys, I'm Jade. Today is my LeetCode review vlog on the 54th problem, spiral matrix. We are given an m times n matrix. We have to return all elements of the matrix in spiral order. Let's see example 1 here. We got a 3 times 3 matrix. We have to return all the elements in a spiral order, which is 1, 2, 3, 6, 9, and 7, 4, 5. Then, let's get started with our intuition to solve the problem. And the key point is called the spiral order traversal. And the detail is we are going to use boundaries to manage the traversal of the matrix in a spiral form, which can be divided into 4 steps. And the first step is move from left to right. Then we have to move from the top to the bottom. And the third step, we have to do a reverse order about left to right, which is right to left. And the final step is move from bottom to top. And if there is still remaining elements, then we have to repeat these 4 steps until all the elements are traversed. Then let's get started with the code and detailed annotations. So the first step is we have to create an array list to record all the elements. Let's say list of integer, called results can be assigned to a new array list. Then we have to pay attention to those edge cases. There are 2 edge cases. The first, when matrix is null, and the second edge cases is matrix dot length is equal to 0. Then we just return the empty array list. And the next step is we have to create 4 boundary variables to help us solve the problem. Let's say the first boundary is top, starting at 0, and the second is bottom boundary, starting at matrix of length minus 1. And the third boundary called left, starting at 0, and the final variable, which is right, starting at matrix of 0 dot length minus 1. Then we can have a while loop to traverse all the elements inside the matrix, while top is less than or equal to bottom, and left should be less than or equal to right. And inside the while loop, we have to do the 4th step as we talked before. And the first step is move from left to right. And the code is we have a for loop. Let's say int I started at left, and I should be less than or equal to right. And we have to increment I after each iteration. And we have to add elements at top of I, and the code is results at matrix of top of I. And out of the for loop, we have to increment top as we have traversed all the elements in the top boundary. And for the second step is move from the top to the bottom, and the code is quite similar. Let's say I started at top, and we have to make sure I is less than or equal to top to bottom. And we have to increment I inside after each iteration. And we have to add the element at matrix of I of right. And out of the for loop, we have to decrement I as we traverse all the elements in the right boundary. Then, for the third step, we have to traverse from the right to the left, which is a reversed order. But there's one thing we have to pay attention to, which is the top variable has been changed before. So the bottom variable we're going to access inside the third for loop could be invalid. So we have to do a further check. And the code is top should be less than or equal to bottom. Then we can have a third for loop. And code is very similar for int I started at right, as we have to do a reversed order. So I should be bigger than or equal to left, and we have to decrement I. And inside the third for loop, we have to ith the element at matrix of bottom of I. And out of the third for loop, we have to decrement bottom as we run out of those elements in the bottom boundary. Then, here comes to our last step. We have to move from the bottom to the top. And we also have to do a further check. This is because our right variable has been changed. Inside, after the second for loop, and we have to access the left pointer inside the fourth for loop, and the left pointer could be invalid, so we have to do another further check. And the code is left than or equal to right. Then we can have a fourth for loop. Let's say I started at bottom, and then I should be bigger than or equal to top, and we have to decrement I as is a reversed order. Then we have to ith the element at matrix of I of left. And out of the fourth for loop, we have to increment left pointer because we have traversed all the elements in the left boundary. And out of the while loop, we just return the result list. And let's run it. Then let's analyze the time and space complexity. So for the time complexity, oops, I got a run variable here, and I have to check it. Is in. So the time complexity could be big O of m times n, where m is the number of rows and n is the number of columns. And each element is only processed one time. And the space complexity, it is big O of m times n. And the space complexity, it is big O of 1. And if we want to say big O of 1, we have to exclude the output list, and there is no additional space is required for the computation. But if the output result array list is considered, the time complexity could be big O of n times n. As we have stored all the elements inside the result list. And this is the end of my LeetCode review vlog on this problem. And I really recommend you can visit my online GitHub page here. I put very detailed problem description, introduction and main idea, Java code with detailed explanation, and the final complexity analysis here. And also my GitHub repository here, which could be visited on this website. Let's say here, top 150 LeetCode quick review notes here. And thank you guys for watching. This is the end of my LeetCode review vlog, and see you next time.